Hey guys, this is the Unit 1, Lesson 12 video. We are in Chapter 6, Section 3 of the textbook, talking about square root functions and inequalities in this lesson. I know some of you guys complained about seeing my face on these videos, so I thought I'd start off the video with my face in here. And now I'm going to go away because I don't like looking at myself. So the content standards that we're going to be focusing on in this lesson are that we're going to look at how to graph a square root and a cube root and a piecewise function. We're also going to look at step functions and absolute value functions. And then our second content standard is we're going to identify the effect on the graph of replacing f of x by f of x plus k or k times x or f of k times x or f of x plus k for some value of k, and we're going to look at positive and negative values, what happens when we put both of those in. And then we're also going to find the value of k given a graph, and we're going to experiment with cases and illustrate an explanation of the effects on the graph using technology. So probably using our calculators for that. And the mathematical practice that we're going to be focusing on in this lesson is constructing a viable argument and critiquing the reasoning of others. So we're going to look at problems and just see, like, are other people doing this correctly? Am I doing this correctly? What am I doing correct? What am I not doing correct? How can I improve the type of process that I'm working on to solve these problems? So in the past, we've simplified expressions with square roots. We did that back in Chapter 4 earlier in this unit. What we're going to do in this lesson is graph and analyze square root functions and then graph square root inequalities. So your new vocabulary, we're going to be looking at a square root function and a radical function and a square root inequality. Okay, our key concept, a square root function, basically, here it starts off with the square root of x. That's the basic function. Here's what the graph of it looks like. It tells you the intercepts. The intercept here obviously is at the origin, so the x-intercept is 0 and the y-intercept is 0. This function does not exist for any negative x values. Notice how there's no graph to the left of the y-axis. It also doesn't exist below the x-axis. There's no negative y values. Remember that if we were trying to take the square root of a negative x value, square root of a negative number, that's an imaginary number. That's why there's nothing over here. And if we look at a negative value over here for the x side, the f of x side, the square root of a number can never be negative, so that's why there's nothing below the axis, below the x-axis, or to the left of the y-axis. So our first example we're going to look at is we're going to practice identifying domain and range. So we need to identify the domain and the range of f of x equals square root of x minus 2. So, as you can see on here, it says the domain only includes values for which the radicand is non-negative. And the radicand, this radicand thing, that is the stuff that is inside the square root. So for this problem, it is the x minus 2. So we want to find when x minus 2 is not negative. So not negative, non-negative means it could be positive, it could be 0. So we're going to write it as an inequality. We're going to solve for x. We add 2 to each side. We get x is greater than or equal to 2. So that tells us the domain is when x is greater than or equal to positive 2. For our range, what you're going to do is you're going to plug in the 2 value in for x. 2 minus 2 is 0, so f of 2 is 0. So that means the lowest value that the graph will ever touch is 0. And then remember, because the graphs, sorry, that's not a straight line at all. If I make an axis kind of like this, let me change my color real quick. Remember, the square root function looks kind of like that. So notice how right here, that's when f of x is 0. It's never going to go below the x-axis for the range. So my range is any value greater than or equal to 0 in the y direction. Remember, f of x is the same as saying y right here. Wow, lots of slides for the same problem. Okay, here's one for you guys to check your progress on. We're going to find the domain in the range of f of x equals 3 times the square root of x plus 4. Pause the video as long as you need. When you have your answer, come on back and check your work. Go ahead and advance to the next slide. Okay, our answer to this one is C. The x values have to be greater than or equal to -4, and the range has to be greater than or equal to 0. Notice how the range always is greater than or equal to 0 if there is no k value after the root. Okay, we've learned how to do transformations of parabolas back in Unit 1, Lesson 7. So now we're going to talk about transformations on square root functions. And notice this formula right here is really, really similar to the formula for vertex form of a parabola. Remember that vertex form of a parabola was a times x minus h squared plus k. So notice that's pretty much the exact same as this square root function transformation formula, except here's a square, here's a square root. Other than that, it's the exact same. H is still our horizontal translation, k is still our vertical translation. A is the orientation and the shape of the problem. So remember, if A is greater than 1, it's stretched up vertically. If it's less than if it's between 0 and 1, it's compressed vertically, it's kind of squashed down, and if it's less than 0, it's flipped over the x-axis. So whereas a normal square root function would look like this, if we have a negative square root, then it would look like this, and if you put them together, it looks like a parabola on its side. So in example 2, we're going to graph the function y equals 3 times the square root of x minus 4 plus 2, and we're going to find the domain in the range afterwards. So what they want us to do with this is we're going to look and figure out what the original function would have been, and then figure out how it's been transformed. So the first thing we're going to start with is our vertex, which is h comma k, and notice that hk would be the 4 and the 2, just pulling it out of the formula. They want us to make a table of values for x values greater than or equal to 4. And if you do that, then you'll get a bunch of other points that are on the graph. What I would suggest you do is that you think about what x values you could plug in here so that when you subtract 4, that the square root will be a whole number. So for example, if I picked 5, like if I just went 1 point over, 5 minus 4, that's 1. You know the square root of 1. That's easy to do. So using an x value of 5 on your table, that's a good choice. If I pick 6, 6 minus 4 is 2. I don't know the square root of 2. So that's going to be kind of hard to graph that point. So maybe I'll skip 6. I don't want to use 6. The next square root I know would be like the square root of 4. So if I used x as 8, 8 minus 4 gives me 4. So the square root of 4, we know that it's just 2. So I might use 4 and then 5 and then 8 for my x values in my table. And then I'll be able to make nice easy numbers for my y side of my table, and then I'll be able to graph the function pretty easily. One thing that's important to look at this is to see that the a value is greater than 1. A is 3 up here. So it's stretched vertically, and it's translated 4 units right and 2 units up from the original graph, because the original graph starts at the origin. Here's our table of values. Notice how they didn't skip 6 and 7. They used those numbers, so they had to approximate here. But if you just use 4, 5, and 8, you get nice whole numbers for your y values. And if you graph that, this is what your graph will look like. Then you want to talk about the domain and the range. Notice how the domain, it starts at 4 and it's any x value greater than or equal to 4. That's what they said here. And this one starts at 2 and it's any y value greater than or equal to 2. And remember, if we go back and look at the equation in a previous slide, we could have figured out this number right here. Because that's 4, it's x and anything greater than 4, and because that's 2, the range is anything greater than or equal to 2. Okay, part B, we're going to graph another function and then find the domain and the range again. Here we've got y equals negative times the square root of x plus 5, and then minus 6. So I think the first thing we're going to do this time is let's write down, before they tell us, let's write down what our h and our k are. Let's write down the vertex. So from this, I can see that h is negative 5. Remember that the formula says x minus h, and this is x minus a negative 5. Two minus signs give us that plus sign right here. And our k value is negative 6. So this tells me I was shifted from the original graph. I was shifted left 5 spaces, and the negative 6, that's the y direction. Negative and y direction is down. So I was shifted left 5 and down 6. And my a value is the thing that's in front of the square root. That's the negative sign, which means it's negative 1, which means it's flipped over the x-axis. So instead of it looking like this, it's not going to look like that. Instead, let me change colors so you can see the difference. It's going to look something like that in green. This thing tells me it's flipped over like that, and it's going to look like this green graph. And this slide's pretty much going to summarize what I just said. Let's go on to the next slide. We're going to pick some other values. We plug them in. We found, notice how, remember, see here they actually skipped some values. They didn't use negative 3 and negative 2. They got their table. We're going to graph our points on the next slide here. So here's our graph. See how it's flipped over the axis. It started at negative 5, negative 6. That's this point right here. And our domain is any value greater than negative 5, greater than or equal to negative 5. And our range is any value less than or equal to negative 6. This time it's less than because the y values are decreasing as you move along this graph. All right, here's one for you guys to check your progress on. Figure out which one is the correct graph of 3 times the square root of x minus 2 minus 3. Remember, you want to start with your vertex. Pause the video as long as you need. When you have your answer, come on back and go to the next slide. And our answer this time is the letter D. And we have another practice one. We've got negative times the square root of x plus 1 minus 4. Which is the time we're only going to be finding the domain and the range. So just start with your vertex and use the coordinates from the vertex to find your domain and your range. Pause the video as long as you need. When you have your answer, come on back and advance to the next slide. And our answer this time is letter A. All right, we're going to pause here and pick up with example 3 in the next video.